Welcome to my first narrated video. In this video I would like to pay a tribute to what I think is one of the pinnacles of Amiga gaming, which is the hired guns game. Let me describe what I will do here. When you start the game and select the short action game, you can see a list of maps to choose from. Back in the day I was always wishing that there were more maps to choose from. It is possible for quite a long time now to create new maps, as the level editor has been released for this game. But how to actually start the newly created maps? You can create a copy of your hired guns directory on your hard drive and replace the old maps with new ones, and then play them even though they look like the old ones in the menu. I think that this feels cheap and ugly. I was thinking of a proper way of adding them into the game. What I came up with is to fill the gaps and add new menu items into the first, second and third pages of the short action map list. You can see that only on the fourth page you have 5 maps to choose from. What I did is that I have added 5 maps also for all the remaining pages. So this gives you 3 more maps to choose from. I know it would be better to add whole new pages, but that seemed as too big of a challenge at first. Now that I have succeeded with adding the 3 maps, it does not feel so unreal, but still I feel like taking a break from this and leave it for some other time. If you just want to take the result, you can find the links to all the modified files in the video description. If you want to see how this was done, then keep on watching. Let's have a look at what we need for this. I know that some people would say, what's the big deal, you just add it to some list and that's it. Shouldn't take longer than 1 hour. Well, let me just say that it takes much longer to figure it out. It took me about 3 weeks to set up the tools and do all the reverse engineering. One problem was that I have very little assembler and reverse engineering experience. So I had to relearn everything from scratch, as I have already forgotten everything about the Motorola assembler. So take it as an encouragement that it is possible to do these things even with little experience. You definitely do not have to be some die-hard hacker to do this. Let's start with the tools we need for the job. We will definitely need the Win UAE emulator, which you can see running, because its built-in debugger is perfect for inspecting the run of an executable, but it is a bit lacking in the user interface department. So for an offline analysis of the hired guns executable, we will need an additional disassembler. I recommend the IDA for this task, as it can handle Amiga hunks without any problems. Hunk is just an Amiga name for a binary executable. IDA provides a very comfortable user interface. You can rename the labels and subroutine names automatically, which is really handy as you progress. It makes reading the assembly code more and more easier. There is one problem though with IDA. It cannot recompile the assembler source it generates. So for us to be able to persist the changes, we will need a reassembler. Reassembler is basically a disassembler which is designed to generate a source code compilable with some other assembler compiler. After many experiments, I have found the IRA reassembler in conjunction with the VSAM compiler to work flawlessly. Let's have a look at the IRA and VSAM. Okay, so the IRA you can easily find on the AVISynth. Okay, so IRA68K, this is the executable we will use. Okay, this is the contents of my WinUAE hard drive. Using a WinUAE hard drive, which is just a mapped Windows folder, is very useful for this reverse engineering task, because it tremendously speeds up all things, because we will constantly switch between the Windows and Amiga environment. So this is really handy, and I really recommend this. So as you can see, I have already placed the IRA68K executable into the hired guns folder. Now about the VASM. This is a bit more complicated. You can download VASM from this page. There are binary releases. But as you can see, there is no Windows release. And if you want to have some reasonably fast compilation, I recommend using the VSAM on Windows. So what I did was that I have installed Cygwin, which is a really handy Linux environment. So we can see the VSAM68K Motorola executable. This is what we will use. We will also need a quality hex editor, because we will be editing binary files all the time. I was using the Hex Workshop, but there are plenty other good hex editors. Another mandatory tool is a C++ compiler, because we will be inserting strings, and this implies some kind of renumbering of existing indices, which are used for referring to these strings. We need to do the renumbering using a custom program, because it is just not feasible to do it manually. I was using Visual Studio's Visual C++, but any reasonable C++ compiler will do, because I haven't written anything fancy or compiler specific. Okay, let's get our hands dirty. First of all, we want to make ourselves familiar with the game files. This is not hard. You just browse in the game directory, open files which seem interesting to in a hex editor, and in general take notice of anything interesting. Naturally, we will start with the main executable itself. When you open up an executable in this stage of the reverse engineering process, the only reasonable thing you can do is to look for hard-coded strings. We immediately notice something strange. There are hard-coded strings, but they are partially corrupt. This is a sign that some crunching or packing has been done on the file. After all, we can see the decompressing text when loading from the floppies, so it is not that much surprising. Now we have to figure out how it was compressed. our best bet is to look at the magic bytes of the file. The magic bytes of the file are RNC. After a bit of googling, we find out that this is a format created by Rob Norton Computing. Eminet provides us with a tool to handle this format at no cost. I did not bother with recompiling the IBM source file because the Amiga executable provided works just fine. You just have to throttle up the CPU speed if you are running out of patience. So this is the last tool we will need to do this hack. So, now that we have the Power Packer downloaded and in place in the hired guns directory, naturally we will want to unpack the hired guns executable. So let's have a look at the options the Power Packer offers. So we will be using the unpack command, and for some reason all the hired guns file use the data file type. So this is so the D option here is what we will always use. We don't need any other options. Let's speed the things up a little bit. Okay, we are done. So as we can see, the hired guns RNC was created. The Power Packer always creates a copy of the file with the RNC extension. So let's try to open it in the hex editor. Now let's look for the strings again. Some interesting strings there. Yes, this is the most interesting part of the executable. This hard-coded string is used in the menu we will be modifying. I will describe the exact structure of this string later on. So you can see that the string is not scrambled anymore, it is quite well readable. Okay, now we need to think a little bit how to find the location in the hired guns code where the key presses are handled. We need to realize that every key on the keyboard has a scan code associated. That is just a number which identifies the key. So we need to do a bit of googling for that to find out what scan code is associated with the F1 key and so on. Okay, so this looks interesting for our purposes. Okay, so we can see that F1 key has a scan code of 80 and the F6 key has a scan code of 85. So this translates to a value of 50 in hexadecimal. But just note the scan code for the F5 key, that's a value of 84. So that's value 54 in hexadecimal. And the reason why I'm looking at F5 is because it is the least common number we should see, we should find in the executable from all those 6. Okay, so let's just look through the executable. Let's just look through the source code in IDA. Well, naturally, I have already found this location, so I know exactly where the key presses are handled. I've renamed this subroutine to test F keys, so there I can find it later on quite easily. But let's just try to search for immediate values of 50. Okay, so this finds quite a lot of values. Let's try to find the value of 54. That's a bit more manageable amount of locations. This doesn't look quite interesting. So eventually you will end up here, and even without having anything renamed, and even without having any labels renamed or something like that, you will immediately note that the scan codes are just all here: F1, F2, F3, F4, F5 and F6. So this has to be the place we are interested in. So let's break the program and open the WinUAE debugger with the Shift F12 keys. Now we would like to place a breakpoint at, for example, this location where the F1 key is pressed. So we need to locate this in WinUAE. So how to find this location? We can see the help for the emulator with the H command. And the search for string or bytes is useful here. We will look for the specific opcode this instruction has. So let's have a look. The address is A40E. So we are at the exact same location, and the opcode for that instruction is this. So let's try to search for this value. Okay, we have 4 locations. Let's try to narrow this even more. Nothing found. Okay, let's try to stick with these 4. So another command we will use is the disassembly get, or whatever that abbreviation is. This will disassemble. This will show in this window the memory location at this address, which will be supplied as a parameter to this command, will be disassembled in this window. This is not exactly what we are looking for, so let's try another. So let's try the next one. This looks familiar, but let's try this in a bigger window. Let's switch to a window which is dedicated for this display, which is this one. You can switch the windows with F keys. So let's press the F5 key and try this command here. Yeah, so we can see the scan codes for F1 to F4, but there is no scan code testing for the F5 and F6 keys. This might be the location of previous menu for player selection or something like that. So let's try the remaining address. Yes, this is exactly the location we are looking for. So we'll just place a breakpoint here with the F command. we do not want to place the breakpoint at exactly this location, because this would break immediately as we would continue in the program execution. We need to place the breakpoint at this location, because this location will be jumped to only if the F key is pressed. So let's just have a look, or not. Let's place the breakpoint there. Okay, so I think that was the F2 key. So let's continue the execution with the G command. Yes, so I have pressed the F2 key and the breakpoint was hit. So let's have a look at IDA. So we have jumped into this label. Yes, and this is the location where we can see the handling of the key presses. So we can see that values are moved into registers, and these values will be used for choosing the map. So so after a bit of experimentation, you will find out that the handler of the F5 key is reached only on the fourth page. On all the other pages, this is just not reached in the code. And obviously the reason are these lines of code. If we are on the first, second or third page, if we are on the first, second or third page, then this instruction is just not reached. So if we want to handle the F5 key even on the first 3 pages, we will have to remove these instructions. About the constant values of 17, 1C and 21. These are actually base numbers for the map file names. The first map file on the first page has the number of 17, which is 23 in decimal. Okay, so let's delete these instructions. And to spare you some disappointment, I will show you another location which needs to be deleted, because there is one more pitfall. Here, near the end of the subroutine, there is one location which also needs to be handled. This is most likely some sanity check to make sure that we aren't choosing a number higher than the actual count of the maps on the page. So we can safely delete these 2 instructions as well. Okay, so let's let's do this modification. Okay, so we will need to disassemble the hired guns executable. For this we will use the IRA disassembler. Let's have a look at the options this offers. So we will use this option to specify the correct processor. We will also use this A option just for clarity, so that we can easily verify if we are looking at the same location as we are looking in the IDA disassembler. Yes, we will also use this option to use the Motorola 68K addressing modes. I'm not sure if this is really needed, but just to be sure. And we will also use the peripherals option. This one will be very important later on when we will be modifying the menu strings. Without this option, the hard-coded strings, well, the embedded data in the executable would be treated as instructions. So we would, without this, the data in the executable would be treated as instructions, and this would make it next to impossible to change the strings. The thing is that the hired guns executable contains only one section, which is a code section, and the data are in this code section. So without this, this disassembler would treat everything as instructions. Okay, we are done. So we can see the output here. So let's just open our favorite text editor. And let's find the location of where the F keys are handled. Okay, so for example, this location, here we see the number A40E in the command, which is the distance from the start of the code section, and exactly this number is here, and we can see that these are the same instructions, so we know we are at the right location. So we will just delete the instructions we were talking about earlier. And also the comparison below. Which is here. So let's save the file and recompile. For this we will need the VSAM assembler again. So this option tells the assembler to produce the Amiga executable, and this is just some compatibility option. Not sure exactly what it does. Probably just some compatibility with some DevPack assembler or something like that. Okay, so this is nothing to worry about. This just tells us that everything went fine. So we can see that the new hired guns executable was produced. So let's pack that executable. Okay, so the packed file is written into the hired guns RNC. Let's create the icon. All we need is to copy this file. And let's edit the tool types. So let's try to press the F5 key. So as we can see, we can already choose a map there. And we can see that this selects the staying alive. So we will need a further modification of the code to select the missing map. So let's have a look at the map directory. As we have seen earlier, the first map for the first page is the 17, which is 23 in decimal. So this is the first map on the first page. The maps before are, I think, the campaign maps and training maps, I think. So we can see that the map 24 is missing, which is exactly the map we will have to add. And in a similar fashion, we can see that the map 32 is missing for the second page, and 36 is missing for the third page. So we will add these missing maps. I've already prepared some very simple maps, simply to put them here and load them. So we have the missing maps in place. And now we have to modify the code to load them. If we are on the first page, we can always tell by the value of 17 in the D0 register. Then instead of 1, we put number 2 into this memory location, and this is how they handle the missing 24 map, so that when you press the F2 key on the first page, normally this would touch the 24 map, but thanks to this, it will be skipped, and the map 25 will be chosen instead. So what we will do is to exploit these gaps while handling the F5 key. So we will add a code here. So this is the location, and I have the modification already prepared. So if we are on the first page, we will not jump to this label, so we will continue to this instruction, and we will exploit that gap, and the map 24 will be loaded, because this is exactly the number which is skipped here. Exactly the same applies for the third page. Here we skip the number 3. So if we are on the third page, we use number 4 instead of number 3. So what we do is that we use the number 3 here. Okay, so let's save this. Let's generate the assembly file. Let's generate the binary file. Yes. We will need to change the instruction type to longer jump because as we have added some instructions, some jump went out of range. So the line is 9502. Let's make a longer jump. Great. Let's pack the file. And let's try to run it. Okay, fingers crossed. We will edit this description later on. So here we go. A new map. So the next step is to add the actual text into the menu, and this is more complicated. So we will need to unpack the executable again. Load it into the hex editor. Okay, so here we are. Here are the credits, and below that we can see the F1, F2, F3 text. So the text is ordered quite chronologically. So first we see the credits, then we see the game type selection, campaign, training, short action game. Then we see the player count selection, 1 player, 2 players, 3 players, 4 players. And then we can see the pages for the short action game. So first map, second map, third map, fourth map, next list, again. So this is the second page, third page, and fourth page. Here is the only location where we see the F5 key being used. So this is what we expect. So naturally what we want to do is to add the F5s also to the other pages. Okay, and because we will be adding strings, we will be inserting, so we will change the length of the executable. And for this reason, we just cannot do this in a hex editor alone. We will need to reassemble. We will need to disassemble the file, edit the data in the disassembled file, and reassemble it again. Just inserting in the hex editor alone would just break all the offsets in the file, and the whole thing would just explode. So let's go back to our disassembled source. And let's try to find the strings. So we can see these long sequences of dollar signs. Let's try to find that. Okay, so we are in roughly the right location. Now we need to pinpoint the location more accurately. So let's find the first occurrence of the F6. This should place us on the first page. Okay, so it is 4636. Okay, so we see the F6. Before that we should see F4, 46, 33 here. Okay, so I'm pretty confident that we are looking at the right place. So we will need to edit this chunk of data. We can do this quite comfortably in the hex editor, but first we will do some pre-processing. So let's take this and remove all the unnecessary parts. Let's remove also all the dollar signs and all the commas. There we go. Now let's take this, create a new file and paste special. There. We can exactly see the F strings. Let's shrink the column so that the structure can be seen very easily. Okay, let's do the same also for the fourth page. We will not be modifying the fourth page, but we needed to be able to copy the row for the F5. So let's find the F5. So we are looking for 46, 35. So there we go. Let's do the same thing. This part of the video is a bit tedious, but I am too lazy to develop some script to do these things. So this is our fourth page. So there we can see the fifth map. So let's take this string and let's insert right here. Let's switch into the insert mode and paste that thing. There we go. So we need to be very careful here. We can see that there are some increasing numbers here. I can tell you right away that we do not need to edit these numbers. These are constant for every page. So these stay the same. So the value of 32 stays for the F5 and so on. But what we need to be very careful about are these increasing numbers. The author of the game chose some high values near the end of the byte range, so that they do not interfere with printable characters, and these high values are used for formatting the strings in the game. And what F6 means is that there will be jump into the language file. Let me show you the language file. Yes, it is the phrasebook file. I just forgot the name. So the F6 means that we will jump into the phrasebook file, and we will look at the offset which are stored in the next 2 bytes. So after F1 we will display the 24th string in the phrasebook file. So we need to think a little bit ahead and change this, even though we didn't touch the phrasebook file yet. And even though I have edited this file, and it looks and the values look quite reasonable, we will have to go. After modifying the phrasebook file, we will have to edit these values again. I will do that later on. So here we have our first page modified. So let's do the same with the remaining pages, page 2 and page 3. So let's go back to the first page in the ASM source. So here we go, here we are on the first page. So I just note that the 40C is the first page. The second page here goes here. So let's repeat the process. Now we need to keep this number, this index, to be the same as on the first page, because the next page string is there only once in the phrasebook file, so the index needs to be the same. So let's just save these files so that we can keep track. We can get lost in this mess quite easily. Okay, here goes the third page. what we need to do is to place these data back into the executable. So here's the first page. Okay, let's just split it into double words beforehand. Yeah, some regular expression could be used here, but I'm just too lazy to look up the regular expression for a line end. Sorry. Now we need to be careful here. Let's move the one we see. Let's move the one we see here to here. And let's delete it here. But I think this won't save us from the trouble of keeping the data word aligned. So I will probably have to go back here and add some data storage instructions here. But we will do this according to the warning which the compiler will generate. Let's delete the old ones. Let's do the same thing for the second page. Okay, so here goes the third page. Okay, let's save the file and let's try to recompile it. Okay, so this is exactly what I was talking about. We definitely need to avoid these warnings because if we ignore them, the assembler will just generate some padding, and this padding tends to break the strings, break the string rendering. So the text would become scrambled. You would get random writes into some memory. Really nasty things. I have seen it. So what we want to do is to keep the data word aligned, and we can see how the word alignment is kept in the other parts of the source file. For example, we can see that if the data storage mnemonic wasn't here, there would only be this byte constant, and this would cause the data not to be word aligned. So the data storage was added here so that the alignment is kept. So we will do exactly the same thing. let's see now. Great. The data are word aligned now, and the additional one I think should not cause any trouble. So we can close these. And now we will have to edit the localized strings. So we will need to unpack. So I will present the modification only for the English file. I have in the complete package with my changes, I have modified all the files, all the language files, because it would not be right to leave them unedited and cause the game to break when somebody chooses a different language. But in this presentation I will only edit the English file. So as we know that every file is compressed, we will need to decompress it. Let's have a look at the content of this file. So this file has basically two parts. One is the list of offsets, and the second part are the strings themselves. So they go all the way to the end of the file. So for example, here we have the staying alive map, which starts here. I know that because every string ends with the F5 value, so the next starts right there. And we can see that we are at the offset of 712. So let's go to the beginning of the file and search for the value of 712. So yes, we can see that this is the place which directs us to the staying alive string. And this always is a 2-byte offset, so we can have a look at the location of the start of this offset, which is 4C. And if we take this value divided by 2 and add 1, we come up with a value which the source code references. So for example, to illustrate this better, I will open up the hired guns executable. So there should be so here's the first page. So here is the so these 2 bytes is the offset. So these 2 bytes is the number of the string in the phrasebook file. F6 always denotes that the next 2 bytes will be the string number. Yes, and this is exactly what we got. So for the new maps, I have here just some placeholder value. We will fix the value to the correct one once we have the strings inserted in the phrasebook file. Now let me just fix the value for the next list string. I need to set it back to this value. I did that wrong the last time. This needs to stay at the value of 28. The reason why I am changing this back is actually that while I was making this video, I discovered that the method I was using was not right, because I was inserting the new map strings in the middle of the phrasebook file, and this turned out to be really unfeasible. So now I am inserting the new map strings to the end of the phrasebook file. So this is why the next list string stays the same, and I need to edit it back. Okay, and for the insertion, I have this tool here. With this tool, we will modify this phrasebook file, and we will insert the new map names to the end of the file. So effectively we are appending these strings, not inserting them. So you might think that you don't really need any program for this. You just appended them and add the new offsets here to the end, but actually you need a program for that, because as you insert the two new offsets here, you actually move all the strings by 4 bytes, and you then also need to increment all the remaining offsets. So this would be a really nasty job without a program. So we need a tool for this. The tool might seem a bit complex, judging by the usage, and this is because before I used to insert the new map strings into the middle of the file. So for example, I have inserted the new map name right here, sort of where it belongs logically. So this tool can do that, but it turned out that it really is not feasible, because if you insert the string into the middle of the file, that means that all the string numbers change, and you also need to renumber all the string numbers in the hired guns executable, and you have to take into account all these tiny data sections with hard-coded strings. At first I thought that there is only really one or two hard-coded strings here, this one and a bit below this one, and this one, but it turns out that there are way more of these data sections, these hard-coded strings. For example, around here, yes, here we can see the strings which print the keyboard shortcuts on screen, and these strings also have the F6 parts. Which look into the phrasebook file, and it just turned out not to be manageable. So it just turned out not to be manageable to to specify all these sections in my edit string tool. So I have reconsidered the situation, and now I am only appending at the end of the file, which really saves a lot of headaches. So as I said, using this file, I will append the new map names about here. So let's do it. So here we can see what the tool will do. It will insert into the phrasebook RNC file. It will produce a phrasebook RNC new1 file as the output. It will insert this map name at the position of 273. We can see the map position. We can see the string position we need with this. This is just a different mode. It just lists the strings. So let's see. Yeah, so this lists all the strings in the file. So we can see that the last string is 272. So we will insert at the position after that. And there are also subsequent files which just take the previous output as input and insert another string. The third file is essentially the same. So let's do this. Okay, first one, second one, and third one. Here's our result. So let's have a look at this file. Yes, so here we go. So this new strings starts at the offset 1EA1. So yes, here we can see the new offsets. So let's calculate the string number which we will need to use in the hired guns binary. So we are at the position 222. So we divide by 2 and add 1. So this is the string number we will use in the executable. So let's modify. Okay, let's pack it. Let's also pack the phrasebook file. And delete it and rename it so that the hired guns executable can see the right file. So here is the modification in all its glory. I can tell you that it really is a relief for the sore eyes to see it, because over the time I really got used to seeing all kinds of errors here and broken strings.